You. Hey, Katie, how are you? Try to get myself all set up here. Ready to go. Hopefully. How's the view, by the way? Can you see the galaxy that we're looking at here? This is going to be M51, or the Whirlpool galaxy that we're currently hanging out with. It's a grand design spiral galaxy, and it's about 23 to 31 million light years away from us here. Really beautiful. This one here is a galaxy. It's a galaxy interacting galaxy or merging galaxy. You can see the clear interaction between the main galaxy, the Whirlpool galaxy, and its a sub-galaxy right next to it. Really beautiful, though. This thing is super beautiful. One of my favorites for sure. It's Messier 51. Yeah, it's very clear. Looks really nice. It's pretty much exactly what it's doing, trying to eat each other. Hi, Julia. How are you doing? Good evening. Angela, good evening. Glorious, good evening. Mitch, what's up, buddy? It's awesome sauce. It's really a beautiful view. These are really gorgeous galaxies. When you see these type of galaxies, and the interaction between them kind of pulled up a little better. But tonight we're using the M51, the C11 telescope with the wider field of view lens, or the camera on it, so we're able to see these larger top objects that we normally don't get to look at when we're using the setup for looking at like Jupiter, for example. It is gorgeous. Really beautiful galaxy. But you can't recognize as well. This is where Whirlpool gets their logo from. This gorgeous one. Hi, Sammy. Welcome back. Good to see you again. There's a lot of supernovae that occur also in this galaxy. So you get to see some really cool brightenings at periods here. 1994 is one of them that I can remember a huge conversation of when I was really young, of being a really cool one here. Last one I can remember, though, was back in, it's been 10, 15 years ago for this one here. The Pinwheel galaxy is also a beautiful one. We had a massive supernovae that occurred there about 3 years ago now. It was really awesome. Hey, Running Bear, how you doing? How's your night? Hi, Kate. How's it going? How's Iceland? See it, real-time movement. It's moving. It is real-time movement. The only difference is obviously distance. It can be moving super fast, which it is, but at the distance, you can barely make it out. As it views as it is, it looks like a snail, and of course, in our view, it'd be moving like a snail, but it's definitely moving very fast. Christy, thank you so much for the New Year's Eve gift. I appreciate that. Thank you, Christy. Hope you all have an amazing evening, by the way, or morning, whichever shall be for you. It is currently 2:30 a.m. here in Kansas City. In the Big Dipper one night. Love it. Super awesome. This is M51, or Messier 51. This is the Whirlpool galaxy. A very gorgeous galaxy. Thought it was moving? I mean, it does. It's just really far away from us. But we're taking long exposure photos currently, though. In order to capture these, you got to do long exposure photos. 3:30 now in New York. I love it. Hi, Tammy. How are you? Good morning. Marcia, good morning. Makes it feel at peace. And that's so true. That is really true. This is going to be one of the targets we go for. Here in a minute, we're going to jump over to another beautiful target that's not too far from where we're actually located. It's going to be a planetary nebula, which is going to be the Owl Nebula. Owl Nebula is really beautiful. Planetary nebulas are similar to what we see here. Ashley, Vonnie, what's going on? I see you. That's way Vonnie in the house. Good evening, or good morning. How are you? Which is really awesome to see S-Wave Vonnie here in the chat, by the way. This is their camera that we're currently using. This is the S-Wave Vonnie's SV405cc camera. There are people in the future. I'll see the Milky Way and Andromeda merge. That'd be really cool. Hi, 18 Killa. How you doing? Telescope right now, C11. running the C11 telescope. Is that live? It is. We're taking photos live right now. We're going to swing over to the Owl Nebula here shortly, though. We'll get to check out a Planetary Nebula. Planetary nebulas are a lot what we see from stars that don't have enough mass to go supernovae, but they go nova instead. Is what we'll be seeing. Yeah, this is the 405 tonight. Yeah, it's looking really good too. Capturing really well. This is 15 minutes of exposure time. Not too bad. Very beautiful. It's the 405 with the C11. Very beautiful for sure. Hi Tariff, how you doing? Can't find the background music. It is a purchased one. It is one that was purchased. Not sure how hard it is to actually find it. I don't even remember where I got it from, but it was one that where you purchased it and got the license. Let me see if I can send this to you real quick. Let's see. Let me. There we go. Hey, Galaxies. Smaller one. What happens to the remaining stars? They all come together. It all comes together through gravity. Eventually, even the cores, both of them here, have actually a massive black hole in them, and they'll eventually come together and merge. Oh, Michael, what's up, brother? Dude, it's been a long time, man. Yeah, it's been a long time. Usually I see the other lady doing your lives, man. I'm glad to see you, bro. Definitely glad to see you, brother. Definitely glad to see you tonight. Now, you guys ready to go check out another target? I think what we'll do is we'll swing over and look at the Owl Nebula real quick. We can do that real quick. Let's take us out of live stacking here. I want to slow down the capture, and you can see how faint this target actually is, but let me speed up the camera real quick. I'm going to bring in a lot of exposure. We're running right now. This is about 2 frames per second. Shows how hard it is to capture some of these type of targets, obviously. Ocean's tapping, yep, that is correct. All right, we're going to swing over to Messier 97, or the Owl Nebula. Here we go. We on our way. On our way. We're going to check it out here. Come out just a bit. See what we're looking at. Then we'll let it settle. Let the stars kind of settle in our view, and we'll plate solve it so we can get it all centered up. Yeah, I forgot the we, didn't I? Forgot the we. All right, and this is going to do a plate solve. You can see here it actually located on the right side of the screen. You can see it actually located where we're trying to be. I'm going to move it over and put it right in the center for us, which is really cool. Oh, hi, how's it going, buddy? How are you doing? How's your night? And then we're going to drop our gain here. Get rid of some of that noise, basically. Run about 30-second photo. Let's see what we capture this time. Should be a lot of fun. That's a very beautiful target, by the way. Really beautiful target. Hi, Luna. How you doing? Look how he's moving by slowly. We're taking photos, so any movement would just be based on just your imagination at this point. But except at that point when we moved around, we were running the camera much faster. But we're taking 30-second exposures, which means basically that we're leaving the lens of the eye open on the camera, or the lens itself, for 30 seconds, so we can capture stuff like that right there. Can y'all see the owl in there? Let me know if it looks like an owl to you. Right in the center here is also what's called a white dwarf star. Hold over properly. But right in the center is what's called the white dwarf star, which is going to be the core of the star that went nova. On January 9th outside, Jupiter opposite. Yo, no way, buddy. That's so awesome. How was the stream? Dude, that is so awesome. I'm great, buddy. I'm doing great. Video right now, but it's behind trees right for me. Picture of Spike and the moon. That is so cool. I love it. Spike is such a beautiful star too. How was your stream, Michael? I missed it. Bro. Wish I would have made it. So this is about 2 photos stacked on top of each other, or about 60 seconds of data currently coming through. And then let me pull out some of the background noise there a little bit. Try to move the histogram a little bit. Make sure you guys can see it here. Hey Alpha, how's it going? It is neat, ain't it? Really gorgeous view of a planetary nebula. This is where a star, when it gets a little too much fusion of heavy elements, and it goes poof. It loses the balance basically of its gravity and its atmospheric pressure, and it just blows out the atmosphere. And then what we see left behind is going to be its core, or that little tiny dot in the center being the white dwarf star. A little bit of red in there. It's going to be hydrogen, yeah. The star went nova, not supernova, but nova. A lot like what we'll see with our sun when it comes to the end of its life in about 5 billion years. Really gorgeous though. Let me kind of back up, get a little sense of how small that area is. Kind of crazy, ain't it? It's really not a big target at all. But it's so cool. It is called the Owl Nebula here. I had an amazing New Year. How was your New Year, bud? Yeah, Crab Nebula comes from a supernova. That's great. What are we want to go to next? Maybe M101? Maybe. That's kind of fun. Get up over to M101. Owl Nebula, that is correct. Yep. Beautiful Owl Nebula. M31's already behind trees for me. I can't get to it. I think M101 would be a good one. The Pinwheel Galaxy is really beautiful. It's a massive based on spiral galaxy up in Ursa Major. What's it called now? It looks like an owl. If you kind of look at it really close here, it almost looks like an owl staring out. That's where it got the name Owl Nebula, of course. Almost has like the eyes of an owl. Hey, how's it going, Sunflower? This is the Owl Nebula. But we're getting ready to swap over. We're going to go to the Pinwheel Galaxy. Looks like an owl. It kind of does. It actually does. The red inside of it's very pretty. That's going to be the hydrogen aspect that we see, where the helium side is going to be the kind of greenish bluish tint of it. We'll get a couple more photos here just to kind of enjoy the view. I like it. I think this is such a gorgeous area. Like, planetary nebulas for me are so beautiful. They're really stunning. Now, the star on the inside, the center, is it's called a white dwarf star, or it's basically just the core of that star that went nova. Just the core that was left behind. Seeing the moon in Ohio yesterday, I love it. Finally got some clear skies. That's awesome. Yeah, that's super awesome. That's super awesome. All right, you guys ready for the next target? Try to get the pinwheel? You're an alien from space night. Oh, thank you, Mick. I appreciate that. Thank you. None done Saturn view in 2006. We'd have to do it in the early evening hours. Right now, it's already set for us. Let me speed up the camera real quick here. Turn up some brightness so we can see some stars out there. Zoom out a little bit. You can faintly see it in there. Like, that's how dim these targets actually are. Some of these targets, I should say. You can barely see it inside the view right there. All right, let's do it though. M101. Let's go to the pinwheel. And we on our way. Feel me? What we're gazing at? That was the. Well, we're gonna go to pinwheel. Never know. Or sorry, Pinwheel Galaxy, which I can barely see it right now coming in. Let me know if you guys can see it right there. It is faint. This has the pinwheel is like a very faint surface feature. It's a relatively harder galaxy to go for. There's Nebulae. Yeah, Nebulae are so beautiful. They honestly are very beautiful. Let me know if you guys can see it right there. See if I put a marker on it real quick. Maybe. Here's going to be where the core of the pinwheel actually is. Right about there. Nerd. That's right. We nerds. You a nerd too? You hanging out with us? We all nerds. All right, here we go though. Let's plate solve this first. Get it centered up a little better. There we go. We're off by 0.07 degrees, which ain't bad. It's just gonna barely give us a little boost here. Put it in the center. Now you can see it's a little bit more centered up for us. Then we'll start capturing this here. Go 120 gain or ISO. 30 seconds. Let's see what we capture. Stack it up. Let's go for it. Grab Nebula. Beautiful. Actually, really cool. Hey, Warrior, how's it going? You can see it, yeah. Now watch what happens, though, when we take the longer exposure. It really makes sense why we do it. What's that, by the way? There's a 9003. I can see it right now. Owl Nebula is a planetary nebula left behind from a star that didn't have enough mass to go supernovae, but it goes nova, rather. Alright, let me back up just a little bit here. Kind of hard to see it. I need to move it on our screen, maybe. Ah, it just ain't big enough to be able to fit on here. See if that works, maybe. Alright, can you guys see the Pinwheel Galaxy? This has a very low surface brightness feature to it, so it's kind of hard to capture. Yeah, it's a massive spiral. It's really beautiful, though. It's really beautiful. Let me do a color calibration here with the stars. See if we can correct the colors. There we go. Make it look a little bit better for us. Yeah, it's beautiful, though, ain't it? Pinwheel Galaxy, this is also known for a lot of supernovae. This one had one, if I remember right, it was like 2.5 years ago. Like 2023, 2024. Love the stars as a kid. It never changed. I love it, man. Absolutely. I love it. Pinwheel. It's called Pinwheel. Pinwheel Galaxy. M101. That winter, that's the main thing. Yeah. The winter gives us better seeing conditions, obviously, when it comes to astronomy. So there's, in a sense, like the winter's actually pretty nice. No bad trap is what I do. And people like don't have that many viewers. Is what. So one screenshot of it. Here, I zoomed in just a bit more. See if it makes it a little easier for you. I'm gonna pause some of the background too. There you go. And the beautiful Pinwheel Galaxy. And you can see this is really, really dim when you talk about the surface of the galaxy itself. Not all that bright, but you do see a lot of the stellar nurseries, the different globular clusters inside of the Pinwheel. Sunflower, they made this thing called Google.com. It's really good for doing silly research like that. You're asking like every question of everything I say. Galaxy started and exploded big. That's true. This one has a lot of supernovae that we see, for sure. Have a nice guy. Space day. Yeah, for sure, brother. For sure. Hey, Ray, how's it going, man? Better way to end the day, for sure. For sure, for sure. It is inspiring. It is. Definitely. I just got to chill a little bit, though. What's going to be the next target, though? That'll be the question. What do we want to go to next? You guys want to see... you guys want to see a comet called 3i Atlas, or no? We do 3i Atlas? Saturn Nebula? Eventually, it's a relatively small object, but it's actually really beautiful. Even like the Snowball Nebula is also really beautiful. We talk about those. I think 3i. What do you guys think about 3i? How do you follow it on here? Click my name on the top, and it should say subscribe. Now to start in the center, see the effects that we see from its black hole. It's not a supermassive black hole, but there's a relatively decent sized black hole. It's not a supermassive one, though. Ladies, already out of my view. Currently out of view. We got 3i Atlas if we can go through it, though. Dealer's choice. Might have to. Have to. We can definitely do 3i Atlas. We can do some Galaxies. We can run by Jupiter real quick if you guys want to see Jupiter for a minute. I am game to go wherever. So looking at the Ring Nebula. Ring Nebula is so beautiful. It actually really is beautiful. One of my favorite. 3i Atlas. Alright, I see two calling them. 3i Atlas. Do it. On our way over there, because it's in the other side of the sky, so let's swing by Jupiter first, and then we'll go to 3i Atlas. Make it kind of fun. Alright, let me speed up our camera, turn up some brightness here so we can see some stars. See where the ring, sorry, not the ring, but the Pinwheel Galaxy is out there still. And 3, 2, 1, and a wee on the ride we go to the other side of the sky. Where's that Nebula? Already out of my view. Pluto's not even above the right. Love the Galilean moons. I do too. I really do. How many visible comets are there right now? Probably 5 or 6 that are relatively visible. And then there's probably, I couldn't even tell you how many that are that we could capture, but they're not very bright at all. Alright, so here's Jupiter, obviously. Let's see if we can take out some of the brightness. It's so crazy bright. Check that out. It gets rid of some of the gain. You can see Jupiter, and it's got 3 of the 4 Galilean moons right here. Gotta move the telescope just a bit, though. Let me speed it up. There's 3 of the 4 Galilean moons showing up currently. See Jupiter out there doing Jupiter things. Kind of cool. Really beautiful planet. Barely make out the striation when we cloud enough. You can kind of see the striation on Jupiter. Let me pull out the back level, the black level too. See a little bit better. It's gorgeous. Callisto Europa, and then Ganymede. Very nice. So Io is either in transit or being occluded. Very awesome. Kind of back up again. See Jupiter one more time. And we'll head off to 3i. See the bands? Ain't that cool? The bands and the zones. The bands that make her dance. Alright, 3i and 3, 2, 1 and a wooey on our way. Get some more light though. Actually see what we're doing. I was in inoculation. Okay, I got you. Included currently. Alright, we'll let it settle for a second, then we'll plate solve. Try to get it all lined up here. Mars or Venus, neither one right now. Neither one in our view currently. Okay. Let's see if we can find 3i Atlas here. I think I see it actually right there. Really, really faint right now. Get rid of the gain and grab a 30-second photo. Let's see what we capture. Stack it up. Yeah, just a few more seconds here and we'll get that first photo of 3i Atlas. Good time to grab some water too, by the way. Alright, let's see what we got. Need more brightness. I forgot to turn on the background here. Or the black level. Gives some more brightness up that way too. Let's see what we got here. I want to clear this out. We're going to need the new photo. I did not get enough brightness. Just so you know, 3i Atlas is super, super faint. Like really, really dim. Pluto, Saturn, neither one are above the horizon currently. Neither one are above the horizon. There we go. Got some of that brightness. There's 3i Atlas starting to come through. Got some more brightness here, there. You guys see 3i Atlas. Let me know if you can see it right there. We're going to try to align it with the comet rather than stars. Let's see how that works. See what our alignment does here. See the tail coming off of 3i Atlas. Lens open longer is the same as stacking. Stacking is where you're taking the images, every image, and you're putting on top of each other and aligning stars to stars. In this case, we're trying to align the comet itself to the comet, so it tries to put all the images on top of each other, just making it really clean looking. You can see the tail. It is amazing. It really is amazing. Thanks, Ella. I appreciate it, buddy. Appreciate that. Yeah, it's just the stacking process is a little different than your exposure. You see here, it is stacking horribly with the comet. Stacking comets is a relatively new feature inside the software that I use for capturing, so it doesn't do that great of a job at all. I'm going to clear it out and we'll see what our next photo looks like though. It is really awesome though, getting to see it. What's the concept of 3i Atlas? 3i Atlas itself is an interstellar object that came through our solar system, obviously. It's from outside of our solar system. But it's a rock, it's just a comet. Didn't see it last time. Yeah, it definitely has a tail. You definitely see the tail on it. Up some of the brightness on it, make it out a little bit easier, hopefully. This is just, again, this is live stacking. We're not doing any kind of like processing or anything. Planet X real? No, Planet 9 ain't even real. Still in trying to figure out, is Planet 9 really a real object or not? That's a great question, but you gotta have Planet 9 before you get to Planet 10. Planet 10 is a conversation like the 1990s. Yeah, definitely ain't gonna align on the comments, so we'll just go with align on stars. We'll let it actually align stars because it's having a hard time trying to do it. Stars said nah. Yeah. Yeah, it honestly never got near us at all. This one is 3i Atlas, yeah. I'm gonna go ahead and clear this out so we can start stacking based on the stars. Matt, what's up, bud? I don't buy her flowers, to be honest. I don't even know that he sells flowers. Matt, that's crazy, brother. Oh, dude, that's horrible. Man. That is so funny, though, dude. There we go. We'll start stacking on the stars. So what's going to happen is we'll see the actual comet itself. As we're stacking to the stars, it's going to appear to trail. And that's because it is moving in different speeds in relationship to the stars that we obviously see in the back. We could stack to the comet, then the stars would make the trail, and the comet itself would be stacked, giving us a little better definition or view. How many interstellar dwarf planets are sitting around the galaxy like they're out? Oh, good question. No clue. No. It is on its way out. It is an outbound object right now. Like 190 million miles away from us right now. It's going to go out towards the plane of Jupiter. That'll be sometime around in March. And then it'll just continue to go outwards. So it'll get roughly in the plane of Jupiter, or the distance of Jupiter from the sun, near its plane, at about the middle of March, roughly. Yeah, Matt, that's a horrible joke, bro. Oh, man. That is funny, though. I'll give you that. That is definitely funny. 3i Atlas, A-T-L-I. Still observable. Yeah, still it is. It still is. I'm still trying to, like, I'm so stuffed up, by the way, from the flu. I'm still trying to get there. I'm sure half of my words don't make any sense right now. It was definitely a good dad joke. I like it. I definitely like it. Yep, 3i Atlas. The Comet Galaxy. Which one is that? Gonna have a rocky road. Yeah, that's true. That's right. Oh, you've been working 13 hours, bro? Dude, that's crazy, Damien. That's too many hours to be working today. Hope you had an amazing weekend, though. Hope you had an amazing weekend. Need a strong drink, maybe. I am just so tired of being stuffy. I feel so much better, though. My energy level's up. It's just I feel stuffy. Nah, it ain't Elon's. Come on, man. It ain't Elon's Tesla. We know what that is. That's your last brain cell running away. Like, get me out of here. Come on, Steven. Had to do it, man. You made it too easy. You opened yourself up for that one. I sound better, do I really? I feel like I sound like crap, to be honest. I feel like crap. Get cough 5 weeks, yo, that's crazy. No way. 5 weeks of coughing. I would not want that. Thanks, Damien. You too, brother. You too. How do you feel about drinking AMFs? Or am I just kidding? What is AMF? I'm not sure what AMFs are. NGC 474. Let me look it up. I ain't sure where it is. 470. Dude, it's not even above the horizon. Come on, Kevin. I mean, Kansas City, if you want to look anything up like that, though. Good church, stronger. This is 3i Atlas. It is. This one would be 3i Atlas. And there's a satellite. Can you guys see the satellite coming through the view? Satellite coming through the view, taking out 3i Atlas. Not really. It's really far away, obviously. I shouldn't say that because some people are very gullible. They would take that way too serious. Way too serious. Nah, this is satellite coming through the view. You can see it continuing on now as we continue to take that photo. Yeah, be a satellite flying through. Pretty cool, huh? This kind of gives you an idea of what does long exposure photos look like. It's how long we're taking a photo. Right now is 30 seconds. So in that 30-second period, we're just capturing a bunch of light. Any movement in there will be detected. And this is how you capture really faint targets. So obviously we're going to capture any satellite that goes through and be able to detect 3i Atlas. Going to be with, I appreciate it, Timothy. There we go. Going to get today. I appreciate it. Hey Keith, how you doing? Good morning. Good morning. Yeah, the whole frame, by the way, kind of more perspective. Let me pull way out of here. So here's the whole frame of the photo that goes to the telescope itself. And these stars are really faint stars. When you look at 3i Atlas, it's like magnitude 17 to 18. In order to see something, you need like magnitude, like under 5. You need magnitude 5 or below in order to be able to see. And this is about magnitude 17, which is a really faint hard object to be able to capture. Leo constellation at the moment, it's not in Leo, it's past Leo now. Let me get it again, exactly where we're at. We are in Cancer. We're all the way up in Cancer now at this point. We're in Cancer, next it'll be heading towards the constellation, in our view, obviously, towards Gemini. I got it. Yeah, exposure is just how long it leaves its eye open. Like if we can leave our eye open and just take in all the light, that's what we're doing right here, and process that one image. In this case, 30 seconds. We're just processing all the light we can capture in 30 seconds. You know, around the shot. So this is what happens here is you get Van-Getting. Really bad in telescopes, and the way to get rid of this, you do what's called flat frames. But this is what's called Van-Getting. Normally what you do if you're doing these type of photos, you do your flat frames, which evens it out, levels it out basically. Just Van-Getting is how cameras tend to capture quite often. One big long single picture so you can get away. More detail. That's correct. Exactly how it works. Exactly how it works. If you want to get more detail, get rid of noise. Then you just take these long exposures. I could put it more perspective for you. This is a really sensitive camera, a lot more sensitive than our eyes, right? So there's 30 seconds right there. This is 30 seconds without trying to actually stack them. I'll go down to like 2 frames per second. Let me back all the way up. Try to gain as much as I can too. So here's a gain with about 2 frames per second. But let's say we want to go to the just under 24, right? 24 frames per second. This is what we would typically see like for video. It's 24 per second. There's like no bright stars in this region at all. None of these stars you would even see. Let me slow back down. But none of these stars you would see with your eyes. None of these stars. They're super faint stars in this area. You want something like, there is a couple of stars nearby, obviously. We can go towards a brighter one over here. Let me see if I can swing this over. So here's a little bit brighter one. This one here you would see with your eye. So it kind of puts in perspective of what we see. So now if we run it back in video mode, you can see that. But if we have to slow it down in order to be able to capture really faint stuff, then this is kind of what we see at that point. This is going to be 15 seconds, and you'll see what it gives us. Had Dilson do, oh man, dude was the worst. Absolutely the worst. Hey, Glory. Definitely good to see you, buddy. Definitely good to see you. But yeah, that's how bright that star is, by the way. Crazy, silly bright. Let me pull out some of the background. That gives you kind of an idea of what do things look like when you're trying to spot really faint objects, by the way. Well, I know I did. Yeah. It was super bright when I turned that on. Yep. This ain't even a bright star by the way. It's a relatively still dim star. But you can see this one with your naked eye. I'm using the SV camera, the SV405cc camera tonight. The advancement in naked eye, that's true. Absolutely true. Cameras are amazing. What cameras can do is just absolutely amazing. Absolutely amazing. Let's see. Let's go back over to M51 one more time. It's my favorite galaxy. I think a lot of people actually like the Whirlpool galaxy itself. I think it's such a beautiful galaxy. Let's fly that way. My telescope was uncovered. Oh no, dude. That's horrible. That is horrible. We're flying back to the other side of the sky. See if we can capture over here. Alright, the target is going to be on the left side. I don't know if you guys can see it properly there. We can kind of see the two galaxies on the left side. I'm going to pull over a little bit. If we can plate solve it here. Could kind of shift over just a bit. It will. Don't want to. Let's do it this way though. Wait, are we? No, we're not centered up. Okay. We clear out our points and then we'll get the center up a little better. Move over real quick and then we'll do our plate solving technique. Get them over. Now what did I see in Gladius? In Titan. It has to be an evening time object. So I have to start like at 6:30, 7 o'clock in the evening to get Saturn right now. We're coming up on the end of Saturn viewing season. So. Took 5 hours to get to see. Oh, that's insane, bro. Can you guys see it coming in right now? In the center? Let me know if you can see the Whirlpool galaxy there. I'll grab a little bit longer detail there for exposure. Pretty wild, ain't it? We'll start stacking this too. Go bust this one. I got no clue. All right, and then we'll capture this though. Let's do it. Get rid of all the gain, the ISO. And we'll take a 30-second photo here. Put it up together. Nothing thinking. Is it allowed for 2 in the morning? Uh-oh. I am tired of being stuffy. There we go. There we go. Oh, we're getting the photo to come through. We can zoom in a little bit. Get some of the details kind of pop for y'all. Pull it up a little bit higher. This is going to be the Whirlpool galaxy here. Do our color calibration while we're sitting here too. Isn't it beautiful galaxy? Star Trek or Star Wars? Star Trek, for sure. Definitely Star Trek. Thanks, Damien. I appreciate it, buddy. And follow you everything in gallery. Location /. I love it. I got you. Absolutely love it. How far it is. Yeah, you're looking at it. That's so true. That's so dang true. And this is so beautiful too. Like the interaction between these two galaxies, they're merging galaxies. The interaction is so amazing. Again, to see interaction on galaxies is just crazy awesome. Let's float there before I go. I got that. Definitely get it. Be a cool destination, huh? I think what's really fun about doing galaxies too, especially these ones, is the depth. You just get a feel for the depth of the cosmos itself. I think that's what makes it really amazing. This is only about 120 seconds worth of photos right now. See if I can bring in a little bit more of the exposure. This is what's called stretching the histogram. So I'm stretching the black level, and this is like the mid level here. You can pull out some of the mid level or mid range of light. How's he climb there? That's your galaxy climb. We're merging with Sagittarius dwarf galaxy. It is a merger. It's a really small galaxy. We've merged with a lot of galaxies, though, in the past, and we'll continue to merge with a lot of galaxies in the future. Looks like water bouncing on a red hot panda, yeah. This is the Whirlpool galaxy. Messier 51 that we're currently looking at. Kind of zoom back out a little bit. A little easier to see in perspective. Really beautiful galaxy. This has to be one of my favorite by far to be able to observe. Definitely one of my favorite galaxies. Some controls, zoom in a little bit here. Not yet. Let me get us to a couple of other galaxies here in just a second. Oh man, I can't remember how big this one is. I have to look up the data. I think this one, I think the Whirlpool is a little bit bigger than. I just can't remember off the top. I got a Hubble image. Kind of have that view. All right, let's do it. Let's go to this other galaxy I want to go check out with us tonight. What I want to swing over to is called Bode's galaxy. And near Bode's galaxy, we'll have the Cigar galaxy as well. Let's swing over that way. Let's head out that way. 3, 2, 1, and away on our way. Cigar galaxy, but they're just more of a big one. So it's a galaxy that's being interacted or being pulled into the Whirlpool. It's also a spiral galaxy. Okay, it's not bigger than the Milky Way. Nice. Having a tug of war, in a sense, yeah. In a sense, yeah. How can we see other galaxies? Telescope cameras. Know how the Whirlpool is made? It's a galaxy from the formation of. It's a good question. How did galaxies actually form? Is a really good question. It's a really good question. A lot of them we see like supermassive black holes in the center, and so in the beginning of time, like something happened where these black holes were formed. But there's still a lot of questions like how's that work? It's a good question. I don't have a true answer for it. All right, let's play solve this real quick. Pull Bodes into the center. Yeah, dude. Oh, 39 yesterday. Oh, that's so cool, dude. Little Planetary Nebula. Very cool. Alright, so this is going to be Bode's galaxy here. Let's see if I can drop some of the gain or the ISO. We'll do a 30-second photo. Antenna galaxy. Very nice. We'll learn there's other galaxies. That was learned by Andromeda back in the early 1900s. She's using variable stars and then determined that Andromeda itself was further away than what the Edgeworth was. Put a black lens and see the sun. We sometimes live stream the sun. Yep, that was a galaxy interacting with another one, or trying to merge with it. Kind of what they're doing. This is going to be Bode's galaxy here that we're going to be looking at. Let's do a color calibration. If it'll let me do it here. Okay. How's Bode's look, by the way? It's a pretty cool galaxy. I know it's not very high in the view. But just, I'm going to kind of pull out some of the brightness here. The mid-range brightness and bring it back in. You can see just how gorgeous Bode's actually is. It's a beautiful galaxy. See the early universe and its early galaxy. With James Webb. Are we southeast? I'm in the Midwest, near Kansas City. This is called Bode. This one is Bode's galaxy. The other one really close to us is called the Cigar galaxy. We'll go to it next and take a look. But Bode's is pretty cool though. Actually has a really beautiful spiral arm to it. The one that's on like your guys' top left. Like I think that spiral arm is so gorgeous. It's a really cool, really beautiful galaxy. Like quasars are that can be seen. They're just, it's not like a simplified method though. It's something you don't do live streaming. The amount of processing, video processing that you gotta do is insane. Nothing explodes and supports them. Yeah, it's insane. The question how they work way outside the context here. Too hypothetical stuff. By controlling telescope. It's got live Discord server. Nice. Those in your community, love it. How far is it? This one here, if I remember right, 12 million light years away? Or is it 20? I can't even remember on this one. Let me look it up. Gotta look it up on this one. I cannot remember on top of my head. I think this one might be 21 million light years away, but I'll check it. No, 12. 12 million light years away. Should stuck with the first answer, right? 12 million light years. Should stuck with the first one. Dang it. I started guessing myself. But see, go. I got you. Okay. Got you. Gotta keep my brain active in that, I guess. So. Alright, let's do a cigar. Really close. Speed up the camera, turn up some gains so we can actually see something here. Let's go to Cigar Galaxy. It's gonna be roughly the same distance too when we talk about Cigar. You can see it kind of coming in right there. More of an edge on Galaxy that we're gonna see. 20, 30 seconds. Let's capture it. Oh, what's a light year? Light year is the distance. It's just a distance measurement. It's how far light can travel in 1 year. That's all it ends up being. It's just a distance. Now, if you want to get into the calculation, it gets really big. Light years are like super math, like 6.77 billion miles per year. It's insane. Huge number. M63. We might check it out. We might go for it. These ones are really fun galaxies currently, though. Get this one start coming through. Look at that. Move it over properly here. This is going to be the Cigar Galaxy. How cool is that? Stunning. What app do you use to help navigate the solar system? For the back end here for the observatory, we use what's called Cartus Ducil. Hey, welcome to go. Lovely. Yeah, John Sturber's Galaxy. Really beautiful too. Like I actually like Galaxy. Really cool. Who names Galaxies? Usually those who discover, but now IAU is a naming convention that's actually or the organization that does the naming. IAU, final say. But usually it'd be from the person who discovers it. Or it can also become more of a collective common name. Thought it was basically more like no, it's the distance measured of how far does light travel in a single period. So if you're talking about light year, how far can light travel in 1 year? It's just a distance measurement. How many stars in our galaxy, or like in this galaxy we're looking at? Couldn't tell you off the top of my head. I'd have to look it up. All these things, like I tried to give the information off the top of my head. Looking it up would be so distracting. So. Does anyone think there are people in those other galaxies? Please reply yes or no. Dang. Good question. Just the Inspired Galaxy, but from the edge. Yeah. Roughly. So this is about 12 million light years away, or the light that we're looking at took about 12 million years to be able to be received here on Earth. At the distance. Hi, Trish. Look at it as we go. I appreciate it, too. I appreciate it, for sure. I do appreciate it. Only Sherry believes in aliens out there, but when it comes to people, I would say that's a tough one. But could there be other life form out there? Yeah. Could there be other people out there? I don't know. Yeah, it's all about distance, not about speed at all. It's just a measurement. Then you hear of other terms like AUs, and you get into more terms, obviously. AU being the distance between Earth and the Sun, being 93 million miles. They use different measurements, same as we do here on Earth, but you use different measurements because of the vastness of the cosmos itself. You have to have some other measurement form that can take into calculation of that vast. Is it Andromeda? Is that right? No. So we're about 5.5 billion years away if we do. If we actually fuse with it. And there's only like a 50% chance that we'll actually merge with Andromeda. Think anything's possible? I agree. I definitely agree with that. Yeah, absolutely, Trish. I'm glad that you're still here with us. Definitely glad to have you here still with us. Yeah, so there's about a 50-50 chance of us actually merging with Andromeda based on better understanding and calculations. But it'd be somewhere about 5.5 billion. And then it'll take a long time. Like 2 large galaxies trying to merge each other takes a minute. Aliens? You an alien, dude. You an alien. What are you trying to call out aliens for? They didn't do nothing to you. Let me find us another target over here real quick. Okay. Yeah, we got much better scene condition tonight. This is the Cigar Galaxy, but we're going to take off to a new target now. I'll speed up the camera. We're going to fly off in the sky. Speed the camera up a little bit here. We're going to fly off in the sky to another target one more time here. And I'll wee on our way. That was a galaxy, yeah. Are we all aliens here? Dang. Calling us out. Black hole aim of all its stars. They really don't do that. Black holes don't just eat anything and everything that they come in contact with. They do tend to break stuff down, speakify them in a sense, or the privacy limit. But they don't just like eat everything. It's just gravity. So things orbit around them like our sun, which it cannot, by the way. It cannot turn into a black hole. But let's say it did turn into a black hole, we would still orbit around in very similar stance because its gravity is still going to maintain itself. All right, let's plate swap this real quick. Make sure we're centered up here. See if we can find this target again. A planet? We might do a planet here in a minute. I think that is a huge misconception, though, when it comes to black holes. And black holes aren't like that thing. It's just going to eat up everything in its area. All right, let's see what we can do. Let's life stack. Baby's waking up. Oh, no. Yeah, absolutely. You're welcome. Absolutely. Black holes probably love pizza. I think everything should love pizza. There we go. Here it comes. Can you guys see the object? Let me know if you can see it there. Let it grab a few more exposures. But this is going to be a 3-eye atlas again. And out at 3-eye atlas. Can't see anything. Just got to give it a minute. We're taking 30-second photos. This is going to be a 3-eye atlas. The interstellar comet coming through. I think there's our life, intelligent life on Earth. That's very possible. Culture, good to see you, buddy. Good to see you. That's just our different pulsating colors radiating from it. What direction? I'm guessing to the south part of the sky, moving off to the west. Starts southeast and moves to the southwest. Which one's 3-eye atlas? Let me put a marker in here real quick. 3-eye atlas, its coma's right here, and the tail moves off in this direction. But 3-eye atlas is the one right there. Now, 3-eye atlas. 3 interstellar and detected by Atlas. Atlas telescope system. Think there's intelligent life on Earth still? I have to hope so. We hope so. like in the early evening, you'd be seeing that. Very possibly you're seeing the Dog Star Sirius. Yeah, there's the universe including your opinion. I get it. Everybody's allowed to have their opinion for sure. Wazamwamwa then. How many interstellar objects have been through our solar system observable from? Oh yeah, that's a great question. That's a really good question. How close to Mars 3i? Yeah, that's really far away. It went past Mars back last year, like in dang October. It's on its way outwards towards Jupiter right now. Oh, where's somewhere? Oh, I got back to 3i Atlas right now. Yeah, for sure. How many interstellar objects came through our solar system? That's a great, really good question. This is the third one I've detected, of course. But I think we'll do, especially if they're, I think we're detecting them a lot easier. You think 3i Atlas is a comet or rock? No, thanks, Joe. I appreciate that. It's just a rock. It's a comet coming through. Interstellar object. Nothing crazy. Just doing the thing it's going to do. Hey, Red, how's it going, buddy? How's your day? Hello again. Chaco, what's up, bud? How you doing? How's your day? There it is, though, y'all. 3i Atlas, doing 3i Atlas things out there. Pretty cool. Definitely pretty cool. We can swing by Jupiter real quick and take a look at Jupiter and Galilean music. Speed up the camera here. Never to return again. Ever. Nothing like it. That's correct. Halley is a stellar comet, where this is a interstellar comet. Yeah, will not return. It is on its way out of here. Now here we go. 3, 2, 1, no, we over towards Jupiter. Hey, look, I can see Io finally. Can you guys see Io right next to Jupiter now? Coming out like a little nose. Looks almost like a little bit of a nose there on the front of Jupiter. If we pull it up a little bit. There we go. There's the 4 Galilean moons around Jupiter itself. Let me zoom out a little bit more here even. There we go. How cool is that? Jupiter and 4 Galilean moons. 4 of the 97 moons. Hey, birthday. The birthday of January 1st. Oh, nice, dude. Very nice. Very nice. It's called Blackout. Conceived on Fool's Day. So, let's see if Planet sends out more. If possible. It does. I mean, obviously this is designed not for planetary views, but I can definitely get it to actually pop out. Put a box around it, actually. We can get it kind of pop out a little better for us. I'm just not going to spend a lot of time focusing on it. Yeah, you can kind of make out the bands. We're not set up to do planetary views right now, though. But getting to see Io right there, coming out right next to Jupiter, pretty cool. The nose. This Jupiter, yeah. You know, Jupiter. It's closer to Jupiter than this moon. What's that? You're talking about 3i. 3i is not near Jupiter yet. Not until March. Gets close in March. Let me zoom back out on the field of view here. Really cool. Beautiful Jupiter. Callisto, Europa, and Jupiter, Io, then Ganymede, in order. January baby right there. Yours on the 20th? Oh, no way. Happy early birthday to you. It'll be coming up quick. Not much longer. Let me kind of swing around over here real quick. Get another target back. And we on our way. That's our moon. Look, the other side. Our moon. We got a beautiful moon. I love our moon. We need more brightness. See what we got here. Get some stars, plate solve this real quick. Another galaxy that we're going to look out at. This is going to be Messier 106. Change the gain up. Take a 30-second photo here. We'll stack it up. Again, 106 is what we're at here. Can you all see it coming through? Check that out. This is actually a massive galaxy. It's a massive spiral galaxy. About like 25 million light years away when we're looking at this one. We can do a color calibration as well. And bring in some brightness. That cool. Such a beautiful galaxy. I'll back up just a bit here too. Ain't that a beautiful one? Well, Chancellor, partners in crime, right? They all fell asleep tonight, didn't they? Just doesn't get old, that's true. Next, we'll do the Sunflower, and then we'll probably call it a night at that point. We'll get the Sunflower Galaxy next. Actually, a really beautiful galaxy, too. Let's do it. Get some amazing screenshots. Awesome. That was so cool. Love it. Always feel free to grab screenshots, by the way. Always feel free to do so. Alright, let's do the Whirlpool the Sunflower Galaxy here. On our way. On our way. It says the diameter of that one was 135,000 light years wide across. Here we are. We're up to the Sunflower Galaxy. It looks like it's in a really good position too. Drop our gain, grab a 30-second photo, stack it up, and let's get it. Go for the new photo. This is a really, really beautiful galaxy, by the way. One of the better ones that we can go to tonight. Besides the Whirlpool, this is one of those kind of interesting galaxies. Kind of a puffy-looking galaxy per se. So we bring in some brightness, not too crazy though. Can you guys see it? Okay, is it coming in okay or no? Hopefully. Should pull it up on my phone and see how it looks too, huh? Hi, Lori. Yeah, okay, awesome. Super awesome. Grab a little bit of details here. The longer we spend time on it, obviously, the better it looks, the more detail you actually get out of it. Imagine being out there and see a live kill. That'd be crazy awesome. Hey, Spy, how are you? How are you? Yeah, have a good night, Tinkala. Thanks for hanging out, buddy. This your new favorite? The sunflower. I think sunflowers are really beautiful galaxy. It really is. It is a beautiful galaxy. Hiccup ring. It is. Very far. This one, how far was it? 37 million light years away. Yeah. Want to go do the math on it? 6.7 trillion times that. How many miles? Insane. So you can't be the only ones. Very possible. I would agree. I think just based on sheer numbers. Absolutely, Ricky. The scale of numbers is insane when you think of the cosmos. Absolutely insane. Kind of back up just a bit here. Give a little bit more perspective of what it looks like out there. Gorgeous, actually. Really beautiful. We'll do a color calibration as well. There we go. Because of the way it's started, like, oh yeah, that pussy look, it looks interesting. Absolutely. Come in on the Pillar of Life. You mean Pillar of Creations and the Eagle Nebula, M16. We capture it. We do capture it. You can see an image of it from this past year on my website, skieslive.com. And by the way, if you guys ever want to jump on our Discord, we got Discord as well. The Eagle. Beautiful Eagle. Absolutely. Right now we're looking at a galaxy called the Sunflower Galaxy. Makes you feel small, right? Absolutely true. Yo, it's so true. So dang true. So darn true. Messier 63, yeah. That it is. Another good one. I was getting ready to disconnect, by the way. Get myself inside. Gotta fix a few things tonight too. But I want to see if we can see the moon real quick before we end the stream. Alright, let's see if we can find it. It's going to be behind trees, but I just want to see if I can see the moon this morning. Now we got this camera hooked up. Kind of interesting view. Didn't get with the moon. And we on our way. If we can find it. Let's slow down the camera as we get a little bit closer, of course. Or speed it up, I should say. We start speeding it up so we don't get blinded by the light. The moon! I see it. See how far back behind trees it actually is. Our beautiful moon out there today. Morning, Mr. Moon. You guys probably don't agree with saying Mr. Moon, huh? Yeah. Let's see. We can get rid of everything here. We don't need hot pixel turned on. We don't need flash turned on. Here's our beautiful moon this morning. Those critters have names. A lot of these do. The one that's really evident in the center is going to be Copernicus, though. The one that needs to be right in the center is Copernicus. Yep. Waning crescent, not waxing. Into the waning. There, thank you. Have a good night, buddy. Hi, Jeff. What's up, man? Came at the right time. Yeah. Hanging out the moon for just a minute here. It's really low in the atmosphere still. Really low in the atmosphere. Let's see if I can. Let's see here. 30 seconds. About some of that gain, so it's not as noisy. Always gotta love the beautiful moon in the morning. Harvest due next week. I wish. Not from here in Kansas City though. Way too small target. Doesn't fly anywhere near us. You like the moon? I do too. Absolutely. Absolutely. Hold over a little better in our screen. What a beautiful moon. Got correct the color there though. Oh, you're welcome. Really, Jenna. With outer space. That's so awesome. Yeah, that's super awesome. I try to live stream as often as I can. Depends on the clouds, the weather here in the city. It just depends on the weather here in Kansas City. Hi, Yellow. How are you? Does it look like heat waves are coming off of it? It's low in the atmosphere, so we're picking up a ton of atmospheric effects, turbulence, more atmosphere. It's only about, how far is it up right now? Let me see how high. Currently about, gotta get my box out of my way. On my way. It's about like 9 degrees above the horizon. So the amount of atmosphere we're looking through is insane. Usually you want to use your telescope on things that are like 20 degrees or higher, even like 25 degrees, but we're looking like 9 degrees on the horizon. You're looking at basically heat waves though. Heat, wind, different elements, dust, moisture, all kinds of wild stuff. Thanks, Rona. I appreciate it. Thank you. I appreciate that. And Galaxy, Andromeda. Not tonight, we didn't. Tonight, we didn't. C11 telescope tonight. How far from it? You mean to the moon? On average, about 238,900 miles away. Light it up for you. That's funny. If we're really good, let's see if we can actually do it right now. I don't know if we can. It may be too low in the atmosphere, but if we're really good at what we do, we can get some of the other side of the moon. Oh yeah, we can. Look at this. This is what's called Earth shine. Make sure it comes up where you guys do as well. Can you kind of make out the edge of the moon there? The opposite side. That's not illuminated. This is what's called Earth shine, though. It's a light from the sun bouncing off our atmosphere and being reflected off and then hitting the moon, of course. Then we can see it a little bit as well. What's called Earth shine. Mars is not above the horizon. We got the Earth shine. That's really cool, ain't it? Have a cool, cool way of viewing stuff. Let me get a little bit more exposure on it too. If we can pull out something. Some of that brightness. Make it out a little bit better. There we go. Ain't that cool? These are probably some of the best things, like when you're in that crescent phase, whether waxing or waning, then you get to see a little bit of that Earth shine. Even with your eyes, when you go outside, you'll be able to kind of make it out as well. You can make out some of this as well, yeah. You can make out some of the details there for sure. Really, really awesome. Yeah, it's crazy. Really cool. You speed the camera back up a little bit here. A little bit more perspective to it. Like you're blowing out the rest of the moon, of course, with exposure, but that's the only way you can really, really pick it up. That was good, yeah. It's actually really cool to get to see. Yeah, it's called Earth shine, though. When you go out and look at it, what you're seeing there is Earth shine. Super cool. Hi, Robert. How you doing, bud? Good morning. You can't see anything right now. Let me turn up more brightness. No moon for about 6 hours for us. Tell him about it. That's true, yeah. The moon itself doesn't disappear. The first time Earth Shiner's here. There you go. I love it. It's actually really cool. This is like, give it a couple more days and then early morning hours about when the sun's getting ready to pop out. But about like an hour before. Probably about an hour before. Run outside and just look at the moon. And you'll just see part of the moon that's not illuminated. You'll be like, oh, that's so cool. Such a cool experience. Foggy blur kind of is in our perspective right now. Alright, let me bring back our exposure here properly. Bring down some of that brightness. Bring it back over for us. Our beautiful moon, of course. Yeah, she's gorgeous. They're so big, 1,000 years across the Milky Way, yeah. Light years across the Milky Way. To a cloud? No, we don't have a cloud right now. It's just the camera picking up extra light off the glass on the telescope with the focal reducer. See if we can get a better region of interest here on the moon itself. Kind of zoom in a little bit. The moon's not hollow. It is not. It has a small iron core, a little bit of nickel to it. There we go. Check out some of these impact craters near the south pole of the moon. Always a beautiful moon. Go the right way. Gotta get the controls down. Alright, let it calm down for a minute. This is a game. What a game. What we're doing? No, these are live views. This is a live view of the moon right now through a telescope. Luna! Hi, Ann. Good morning. We could focus a little bit. You can see it right on the edge. I don't know if you guys can make it out, but I can definitely tell we can focus a little bit here. Give us a better view, but we're not going to worry about it. Want to see the dark side of the moon? Right there next to us, on the right side. Dark side of the moon. The night phase. The moon itself don't have a true dark side of the moon at all. That's just a song. That's just a song. I've seen all that's right. Yeah. Information overload. Information overload. Alright, y'all. I'm gonna jump off. Get stuff done that I've been wanting to do. Got a lot of things here in the observatory need done. But I appreciate y'all for hanging out tonight. Tomorrow night, we'll see how things go. The other side doesn't rotate right. It does rotate. The moon itself rotates, but the other side's called the far side. But it even receives sunlight. So when where we're seeing under 50% right now, let's say if we're looking at 45%, that means 65% of the far side right now is also illuminated. So at all times 50% of the moon itself is illuminated. So on the far side, we'd see about 65%. So we see about 45% illuminated on this side. But at all times, 50% of the moon itself is illuminated. Come in, please. Now we're going to jump off for tonight. But tomorrow night, let's see how things go. Hopefully a little bit sooner. If we do, we'll try for Saturn a little bit. We shall see. We shall see how the day goes. Clear skies, y'all. If you want to jump on our Discord, feel free to jump on our Discord, by the way. It's discord.skiesalive.com, or what the context here says. We got remote telescopes that you guys can operate from here at the observatory. All kinds of fun stuff. Keep up the communication, the chat when we're not live. Plus, you'll know when we're going live and what the plans are. But clear skies, y'all. We'll see y'all soon. And be kind, by the way. We'll see y'all soon. Thanks, Jenny. Good night, y'all.